In today's lesson, we're going to be learning about solving linear equations in one variable, part 2. Now, in today's lesson, we're going to do the exact same thing as our previous lesson, which was part 1 of solving linear equations in one variable, with 2 exceptions. One, we're going to be solving equations with fractions, and the strategy in order to deal with that is to clear the fractions using the LCD, or least common denominator. The second exception will occur with decimals, and the strategy for getting rid of decimals is to multiply by a power of 10 to get rid of the decimals. Now, the power of 10 that you multiply both sides of the equation to get rid of decimals is going to be determined by the highest number of decimal places you have in that equation. So if the highest number of decimal places you have in your equation happens to be 2, you would multiply the whole equation by 10 to the power of 2, or 100. So let's move on to our first example. So here we have negative 2 equals negative 1 minus 12 over 5x minus 18 over 5. And again, our strategy to solving this is going to be multiplying both sides by the LCD. So the LCD in this case, well, it's just 5, because these are the only fractions in our equation. Okay, so what we're going to do is multiply both sides by our LCD, or 5. So on the left side, we're going to get negative 10. All right, so we're going to multiply the right side by 5. And when we do that, we get negative 5, right? 5 times negative 1 is negative 5. 5 times negative 12 over 5, well, the 5s are going to cancel. So we're going to get minus 12x. And we're going to multiply 5 times negative 18 over 5. And again, the 5s cancel. So we just get negative 18. And as you can see, we can cancel the right side of our equation. So we get negative 12x minus. So negative 5 and negative 18 is going to be negative 23. And again, at this point, we can just solve for the unknown by isolating x. I want my variable on the left side, so I'm going to add 12x to both sides. If we do that, we get 12x minus 10 equals, so these 12x's cancel out, and we get negative 23. Now what we have to do is move our negative 10 to the right side, and we can do that by adding 10 to both sides. And the 10s cancel. We get 12x equals negative 23, and positive 10 is going to be negative 13. Okay, and to fully isolate x, we can divide both sides by 12. And when we do that, we get x equals negative 13 over 12. And that is going to be our answer. And I'll leave it up to you to see if we did this correctly by checking our answer. Let's move on to our second example. Here we have negative 5 over 2 times the quantity of negative 1/2 x minus 4 plus x equals negative 1 times the quantity of 9x plus 5 over 2 minus 1. So again, what we want to do is multiply both sides of the equation by the LCD of the fractions involved. But before we do that, we can actually simplify, right? So we can use the distributive property to simplify both sides. Here, the negative just means there's a negative 1 there. So there's a negative 1 multiplying the quantity of 9x plus 5 over 2. So for the left side, I'm going to multiply negative 5 over 2 and negative 1/2. That's going to give us 5 over 4x. Negative 5 over 2 times the negative 4 is going to be a positive. So we can cross simplify. So we get, here we have negative 5 times negative 2, which is a positive 10. Okay, and then plus x equals, okay, on the right side, when we distribute the negative, we get negative 9x and negative 5 over 2. And don't forget your minus 1. Now we can clear the fractions by multiplying both sides by the LCD. What are the fractions involved here? Well, it's 4 and 2. So the LCD of 2 and 4, well, it's 4, right? So let's go ahead and multiply both sides by 4. When we do that, we get, on the left side, 5x, right? Because the 4s are going to cancel each other out. So we get 5x plus 4 times 10 is 40. 4 times x is 4x equals, here we have 4 times a negative 9x, that's negative 36x. 4 times a negative 5 over 2. The 2 is going to go into 4 twice. So basically, it's the same thing as multiplying 2 by 5, which is 10. And then 4 times a negative 4 is going to be negative 4. And again, one of the keys or skills that you need to have in order to solve these things is to see what can be simplified. So as you can see, there are things we can simplify on both sides of this equation. So here we have 5x and 4x, so we can combine those two. We get 9x plus 40 equals, on the right side, we get negative 30x, 36x, and then negative 10 and negative 4 is going to be negative 14. All right. And again, at this point, once we've cleared the fractions, we can just solve the equation using what we know from our previous lesson, which is isolating x on one side and moving everything else to the other side. So I'm going to add 36x to both sides. And then I'm going to subtract negative 40 from both sides. That's going to cancel, and that's going to cancel. So we have on the left 9x plus 36x, which is 45x, equals. On the right side, we have negative 14 and negative 40. That's going to be negative 54. All right, so here we have 45x equals negative 54. To get rid of the 45, we can divide both sides by 45. And when we do that, we get x equals negative 54 over 45. Now, this is the correct answer. However, I believe your teachers are going to want your answers in reduced form or simplified form. So this fraction actually has a greatest common factor, GCF, of 9. So we're going to divide the top and bottom by 9. Okay, and when we do that, we get negative 6 over 5, right? 9 goes into 54 6 times. And that's going to be your answer, negative 6 over 5. And once again, I'm going to leave it up to you to see if we did this correctly. Okay. Now let's try a problem with decimals. So the way we get rid of decimals in a linear equation in one variable is to multiply it by a power of 10 that allows you to get rid of the decimal places. So, and that's going to be determined by, so the power of 10 is going to be determined by the highest number of decimal places that you have in your equation. So in this case, it's 1, right? We just have one number behind the decimal place, and that's the highest. So we would multiply by a power of 10 to the first power, which is 10. So let's do that. Let's multiply both sides by 10. However, we can see that we can actually simplify the left side of the equation by using the distributive property. Okay, so when we distribute the negative, we get 4x plus 6.6, and then plus 7 equals negative 9.4. Now we can multiply both sides by 10. So let's do that. When we multiply, so 10 times 4x is 40x. 10 times 6.6, well, that's going to be 66. Anytime you multiply a number with decimals by 10 or 100 or whatever, you can simply move the decimal place, move the decimal to the right by the number of zeros that you're multiplying the number with. So if you were multiplying by 100, you would move the decimal place twice to the right. But here we're multiplying by 10, so you would move the decimal place one time to your right, which would give us 66. 10 times 7 is 70. And then 10 times negative 9.4 is going to be 94. Right? All you have to do is move the decimal place to the right. Now, we can actually simplify the left side of this equation. When we do that, we get 40x plus 136. Right? 66 plus 70 is 136. Equals negative 94. To isolate x, we can subtract 136 from both sides. And that'll give us 40x on the left side. And then since we have two negatives here, we can just add the two numbers. And when we do that, we get negative 230. Okay. And to fully isolate x, we would divide both sides by 40. And when we do that, we get x equals negative 230 over 40. And again, just like before, we can actually reduce this fraction because there's a GCF of 10, right? So we're going to multiply the top and bottom by the GCF of 10. And that's going to give us negative 23 over 4. And that's our answer. And since we started with decimals, if you wanted to answer this problem, if you wanted your solution as a decimal, you could convert the negative 23 over 4 into negative 5.75. Right? These would be equally valid answers. So the last part of a lesson has to do with the types of linear equations in one variable. There's actually three types of linear equations you can run into. First is called conditional, and that is when you have exactly one solution. So we can solve for x in this example, and that'll give us, so we have 3x equals 6 and x equals 2. So since we have only one solution, this would be considered a conditional equation. The second type of equation is called a contradiction, and that is when there is no solution. So here we have 7x minus 35 equals 5x plus 2x minus 27. So let's try solving this. Now we can simplify the right side into 7x minus 27. On the left side, we can just leave it alone. Notice we have something interesting going on here. We have 7x on the left side and we have 7x on the right side. So immediately it should ring some alarm bells in your head saying, this is not the regular type of equation that we're used to solving. And you'll see why. So we're going to subtract negative 7x from both sides. And when we do that, notice how we get negative 35 on the left side and negative 27 on the right side. Now, negative 35 does not equal negative 27. This is called a false statement. So anytime you get a situation where you get a false equation, such as the one that we have here, the answer is going to be no solution. And you can write your answer as simply no solution, or you can write it as an empty set, or a null set, like that. Okay, all these would be valid forms of an answer. All right, the third type of equation that we have is called an identity, and that is where you get into a situation where you have an infinite number of solutions. So here we have an example where we can simplify the right side using the distributive property. right? We're going to multiply both of those things by 3, and you can see that what we get is 3 minus 9x. Notice how we have 3 minus 9x on the left side as well. So we get an identity when what happens is we get an identity when we get the same things on both sides of the equation. So it doesn't matter what number you plug in for x, you're always going to get the same thing for the left side and the right side. So if you plugged in x equals 0, what would happen is, well, 9 times 0 is 0. So you would have 3 on the left side and 3 on the right side. So you would get this type of situation for any value of x. And that is what's called an identity. Now, I'm a firm believer in the idea that the only way to truly learn math is to learn by doing. So for those who really want to learn the subject, there's a link to practice problems in the description below. I'll see you next time.